Appreciate it. Good morning, everybody. Bill's a tough act to follow. He's got a lot of energy for this early in the morning. But I think what's exciting about it is that he's probably echoing the excitement we all have, because this is the best time you could possibly be in the data center industry. There's so much going on and so much opportunity. So we've all got to go out and get ahead of it. Appreciate you spending the morning with me. We'll talk a little bit about some of the things that I learned. We are talking about bridging the gap between air, liquid cooling and air. And I think it's been an interesting thing. The show so far, just in the last 3 days, which is why my voice is going, so I apologize for that, has been unbelievably exciting and really, really busy. And we're learning things every week and every day as we go through this process. I think you all heard earlier in the week, the folks from Intel and AMD in one of the sessions they were talking about is that we're all trying to figure out how to build data centers and to architect the new way of doing things, while they're figuring out how to change the stuff that's going on top of it while we're all moving. So it's a very dynamic environment. I scrapped my normal presentation that we do, and I kind of rewrote it based on just the things that we've been talking about in the last 3 or 4 days here at the show. And we want to talk about the fact that there's a couple of problems that we see. We're trying to figure out how to solve for them and make it more efficient, and let you know that there is a bridge between liquid and air in a way that we can possibly manage some of these things more efficiently. For those of you who don't know me, I'm Chris Orlando. I'm the founder of DDC and ScaleMatrix Data Centers. You probably know Jensen Huang a little better, so I put his picture up there. He likes our stuff because we can put a whole lot of DGX and enterprise-type AI applications inside our cabinets. And so we're excited to show you a little bit about what we do and how we're solving some of the problems in the industry today. So these are the 5 that we're focusing on today in this talk. Things that we've just had real candid conversations with operators today at the show. Things about variable density workloads and how we solve for those. This one-size-fits-all clearly doesn't work anymore. And so it's something that we're all having to try to adjust to at the data center level, and we're having to do it quickly. Resource management is obviously a challenge no matter what you talk about. And you'll hear later in this hour how power is becoming one of the catalysts for obviously everything we're doing and how we try to stay ahead of that moving forward. It's not just cost, it's overall efficiency and how we're using water and power that are going to help drive how this industry evolves in this rapidly changing time. Talking about data and having the data to be able to make more intelligent decisions. We know that the data will set us free. We need it in order to make those good decisions. Operating the blind, not knowing what's happening at the rack level is challenging, and it's going to be something we have to work on. Cost is obviously a driver, not just from a power perspective, but from an operations platform. And if you look at things like rear door and other types of ways that we're adjusting for heat, they certainly are solving the thermal challenge, but are they helping us drive down operational cost and build costs for these data centers that are trying to keep up with the changing workloads? Something we'll explore a little bit more in depth. And then speed of deployment, right? What's the mandate today? Go faster, take data centers where they've never been before, and we want it all right now. So we got to figure out how we get into that quickly. So let's start with the variable density workload challenges. The things that we're seeing that are out there is, do I need liquid? A lot of talk about liquid. And it's definitely something that we have to do for the AI workloads, but there's a whole lot of other workloads, enterprise workloads, networking workloads, that aren't going to go away. While AI is going to grow exponentially in the next 3 or 4 years, traditional workloads are expected to 8 times X in the next 4 years. So what do we do with those workloads? We have to figure out how to operate those as efficiently as possible. If you have a bunch of air-cooled workloads in your data center, how do you manage those efficiently at different densities, right? How do we design data centers that may not be ready to go to liquid so that we can manage variable density workloads and not strand assets in the data center, not make poor use of the liquid and power resources that we have in existing legacy facilities? And then of course, new hardware constraints. You've got more networking and more cabling requirements that are happening at the data center level. We've got to be able to cool those things in an air-cooled environment. So how are we adjusting to those today? We designed about 12 years ago, after operating our data centers across North America, there's 5 of them that all run the DDC platform. We took everything from the data center and we concatenated down to a single cabinet. Right? Airflow management, temperature management, all those type of things. And we built a bunch of the functionality that we thought into that. And what we learned over the last 10 years is that while we used to look at the data center at this level, And then we started to get a little more intelligent looking at the row level. It's really, with the differences in hardware and workloads today, being able to adjust at the rack level to give that one rack a very, very precision amount of environmental condition, the right amount of power, the right amount of cooling, can save us a tremendous amount of money in operating costs. It can actually make your hardware run a lot better. We believe that in traditionally built data centers that need to advance and kind of upgrade for the next generation of workloads, that variable density is something we have to learn to solve for. And so if you think about it from a platform level, if you can build a solution that allows you to say, hey, today this rack load is going to be 5 kilowatts, the next one will be 20, this one's going to be 65, you can do that somewhat ubiquitously without any real impact to your cost of operations. Data center management becomes easier, your costs go down, and the equipment that you're running generally is happier. So this dynamic allocation, which is where DDC comes from, dynamic density control, is the ability to dynamically manage your data center at the rack level and migrate resources, cooling, and assets around the data center whenever you need to. That solution is actually pretty cool. Our cabinets, if you haven't come and seen us, we've got a booth right at the front of the show, do that by doing a forced air system on the front cold side plenum where we're only worried about cooling the air in front of the cabinet. Right? As that air is consumed and heated up, it comes across the back end of the cabinet, and we bring it out the top and put it right across the heated chiller right back into it. By doing that, we have really precision control about what happens at the rack level. We can cool messes like this where there's both front side and rear side cabling in a cabinet, but we've got to keep airflow and temperature management going despite all that mess. And we do so in a really, really efficient way because we're no longer worried about this environment. We're just worried about the few cubic feet right in front of that critical hardware that's running our applications. So we believe that variable density and this type of enclosed management is a great way of dealing with those demands that are coming down the pipe. If we look at resource management as a challenge, right, power and cost availability, which you'll hear later this hour, is obviously a critical concern. Water usage is becoming a pretty big issue, right? Whether it's the cost of evaporative water and all the news about how much water we're burning in our data centers, or whether it's actually the availability of water overall, it's a limiting factor that we have to think about. And then planning my data centers, right? What do I build for? Do I build a small area of higher density? Do I put my networking gear here? I've got my enterprise applications. How do you plan which one's going to grow faster and how you should design each rack in the data center to manage that? Those are challenges, and it's hard to predict. We don't have a crystal ball to do so. So if you can build them in a flexible manner, where each of them can change over the next 2 to 5 or 3 tech cycles, that gives you the option to be more flexible in the data center and try to future-proof, even though we don't know where things are changing, because it's all happening so quickly. One way to adjust for that is to take rack-level information and put it in the hands of the people driving. If you can operate your data center with this level of information, where you know at each rack level, everything that's happening from how much water are we consuming, how much air are we consuming, how variable is the temperature management based on the variation of the workloads. If you have that data, you can make better decisions about how we're operating the data centers that we're running. We can run them more efficiently at less cost, and we can flex when those workloads change over those tech and IT refresh cycles. So let's look at data, right? We used to operate somewhat in the blind. There's a couple of us, I'm sure, that operate data centers where if there's a hot spot that happens, we don't know about it in time to solve for the problem. The beauty of taking the data center down to the rack level is you realize instantly when there's a change in workload, there's an issue with cooling, you're able to respond to those things in real time. With our platform, the software does most of the response for you, automatic reallocating water and airflow to those cabinets to try to solve for those things before they actually become an issue. The better data we have, the happier the equipment we run is, and oftentimes the further we can drive down cost by efficiently using all of those resources. We do this, again, by showing the customer a lot of data, right? If you're tracking all of that telemetry and you know in real time what's happening with load dynamics, you can adjust the amount of resources in the data center based on what's needed. And doing so has given us, through a couple different use cases, the ability to really drive down costs and increase customer satisfaction level in the data center because of all this information we're using to drive these decisions. Operating costs is another challenge that we're working on, right? Everything from cost to build to cost to operate. Lots of solutions out there. I was told by one of the guys that visited our booth yesterday, there's a lot of solutions here at their show, a lot of pieces to the puzzle, but you guys have programmed a bunch of those pieces into one box and made it easy for us to consume those kind of fixes to density. And it was a great compliment we received from that customer, but that's really what we were striving for. Can we build a platform that solves a bunch of the current data center changes and gives you just enough headroom to stay ahead of changing workloads over time? And so that's been a really exciting thing that we've heard more and more about the show, and a lot of folk coming up to us saying, hey, I think this solution might work for us. And of course, as workloads change, we've got to be able to flex and be variable in the way we solve for the different changing workloads. I could say all day long how great our solutions are and things of that nature, but it's great to hear a third party from a customer, how these things translate into the real world. So in a recent project that we did with the folks at TierPoint, they operate 40 different markets, almost 100 total data centers. They wanted to put up 16 megawatts of site. They had about 8 months to do it, and that project's launched in Pennsylvania recently. On the left side, you see the site we built. On the right side, you see the 350 cabinets that are built out, running at over 50 kilowatts per rack, 16 megawatts in a very, very small footprint. And they went through some extensive work to try to figure out how to do this better. And they looked at the solutions that are available to customers today, right? Do I go with a containment solution? Do I go with a rear door heat exchanger solution? Or do I go with a more overall solution where it kind of concatenates all of those solutions into one? And that was DDC. So they spent a lot of time and engineering resources doing this test. And they came across, and we won in a lot of categories. And it was great to see that a third party has realized all the value that we had tried to engineer into this solution. But in the end, the numbers kind of speak for themselves. If you can figure out how to do a 30% cost reduction over one operating model, reduce your overall PUE by 44%, do a containment savings of 12% overall, that's a lot of money, and we help them get to that solution in just under 8 months. So speed to market, all those type of things really critical, and that's a demand right now that's happening across the market. We need to help customers try to get there quicker because this is what they're looking for. And they did another comparison between some of the things that we could do from a chilled door perspective. It's a great solution, but if you're looking for something with a little bit more longevity that will solve larger problems in the data center, you may want to come check out the S-Series product line. Lastly, everyone's under the gun right now. Speed of deployment is critical. Everybody wants everything yesterday, and the race is on, right? So building at the edge is also a challenge, right? They want us to take data centers and get them closer to where the workloads are happening, and that's a challenge. Building data centers is not a fast prospect, but if you take a bunch of the data center functions and you actually put them into the cabinet and then really just have to worry about building the infrastructure, power and water to cool it, right, you can take away some of the timeline in these build constructions. And so that's what we've done. This was a multi-megawatt project that we did for a customer in just 2 weeks. We went from raw warehouse space to multiple megawatts lit and deployed in just 14 days. And here's one of the reasons why, right? All the things at the bottom of the screen there, you see raised floors, fire suppression, et cetera, the things you don't have to plan for because they're integrated into the box. And so anywhere we can, we're trying to help customers do more density, manage density in a variable way, lower their infrastructure costs, and get to market faster. And so that's one of the things that we've been focused on here in the last year, and obviously the demand only continues to increase. And with the S-Series, because it is enclosed, right, we can put the cabinets just about anywhere. One of the most unique deployments we did was on the USS Enterprise in the San Diego Bay, where we had to get the cabinets through an actual bulkhead door and deploy it. But they had caustic air, all kinds of issues with dirt and cleanliness, and the cabinet, because it's sealed, helped them address those particular problems. So all kinds of unique things that help us get to market faster and take data centers where they have not been before. Modular solutions, this actual product line that we've got is actually sitting on the trade show floor running a live GPU environment. If you haven't come by our booth yet and seen that, come by and see it. That's something that 2 guys can set up in an afternoon, and you can drop it into a manufacturing location. You can drop it into a retail location. Wherever you need high density cooling in a manner that can be deployed very rapidly at a very low cost. That's one of the things we're doing with this new kind of data center in a box type solution. And while a picture's worth 1,000 words, I'm going to go through just a little bit of a video here and talk about some of the highlights. Our marketing team does a much better job of highlighting some of the product features, so we'll show you guys some of the deployments that we've got around the world. These, like I mentioned, the data center platform was designed for our data centers over 12 years ago, and it's been tested. In a colo environment, you can't control what type of infrastructure customers are going to bring. So over the last decade, our customers have brought every imaginable type of hardware with every workload, and we do them across 5 sites around the United States. We've never had to tell a customer we can't do what you need. And as things progress and as densities have increased, the system dynamically just draws more cooling and more airflow into its loop, and we're able to reduce our costs significantly by doing so, right? We call it a liquid-air hybrid platform because we are doing heat exchange at the cabinet level with liquid. The liquid is not inside the actual IT environment itself, so it's extremely safe. You get to continue to rack equipment just like you have for the last 50 years in a 4-post rack. It just happens to be in an enclosed cabinet that has a localized heat exchanger. And that design that you see right there allows us to precision control the temperature of the air and the amount of CFM per kW deployed at the rack level. And those new metrics that we're measuring our data center performance by are really critical. And this is one of the solutions that helps you dial it in surgically. So you can control exactly how many CFM and exactly how much temperature management and set points you need. You got a rack full of GPU servers, stick them in the cabinet. If 2 years from now they don't belong there and you want to move them to another area of the data center, move them to another area of the data center, that resource allocation will switch to, the cabinet that you pulled them out of will switch to whatever the new hardware profile you were in, all because of our intelligent sensing and management of power and resources. The cabinets also integrate a bunch of the other data center functions that you have, like fire suppression, right? So that you don't have to, it helps shorten your deployment cycle, less permitting work that has to happen in the data center. And it also helps isolate your fault tolerance zones. So if there is an issue at the cabinet level, it just affects that one cabinet, which is a really great thing. People ask about cable management inside the racks. There's tons and tons of ways to integrate cabling between the two racks while still managing that airflow envelope that helps drive that efficiency and that extremely high density. One of the things we talk about in some of those graphics is velocity augmentation. By pushing air in a pressurized way at the front of the cabinet and pulling air at the back, we're actually able to manage the static pressure across the server and across the coil inside the cabinet, which helps drive efficiency through the roof and helps us cool density workloads that traditionally may not be able to be cooled with a regular air-cooled solution. It's been fascinating, the number of customers that have come to us and shown us, hey, this is our workload, this is where we need to put it, let's try. We have a demo lab in San Diego where we take customers' hardware, we run it, we prove out that it's going to work the way it should, and once we do, we can ship cabinets anywhere in the world from a variety of different locations, and you get all this type of real-world control, visualization, and software as part of the solution. I think if we talk about those 5 challenges that we saw again, going to market, reducing cost, managing energy, all those things, that's what we've spent the last 10 years working on from an engineering perspective. And I think the time is now in the market to be able to solve for some of those things. I think that's my time this morning, so I appreciate being able to share all this with you. If you guys are interested, please come by our booth. We're right up front. I'd love to share some of this information. We're happy to share the white paper on the TierPoint case study so you can dig into some of the facts and see how they did deploying our technology. Thanks very much for your time this morning.